Yeah. In this part, we will solve another problem, activity selection problem. This problem has a property like this. So why I choose this example. In this example, we will see when we use greedy algorithm, we can solve the problem easily, but there is still a very hard part, prove optimality. So that's the point I want to address in this example. Yeah. The proof part, very, relatively hard, because it is very abstract. It is a little hard to follow. So I try my best to explain it, but still a little hard to follow. But here I may like to say a few words related to the final. For the final, for lecture 12 part, for the final, just let you know, on Wednesday I will give you a review session. Wednesday's class, the last class of this semester. I will give you a list of question types you may have, just information about the final. Examples, question types, distributions, that kind of information. And explain some common problems in your homework number 3 and number 2 and number 3. Number 4, I will use another later video after I grade your homework assignment number 4. That's the Wednesday's last lecture. Regarding this part, lecture 12 part, in the final, I will have some questions, but I will not give you the relatively hard part. I will check your basic understanding. Greedy algorithm, dynamic programming, the properties, but the basic knowledge. I do not ask you to solve any problem directly using dynamic programming or greedy algorithm. I skip that part. Okay? So do not worry too much about this last chapter. But this topic is important. So if you really want to, improve your problem solving skills, you should learn this topic, with good understanding. All right, so let's work on this example. First, let me give you the description, problem description first. This is our problem number 25. Given a set of activities, so here, this is our activity list. But how do you define an activity? For each symbol, how do you define an activity? So we use an interval to define. Each activity, you have a start time and end time. That interval is used to define an activity. Each activity AI associated with a start time SI and a finish time FI. Like this. Then, so we have many activities, but you can think about some of the activities may have overlap. So their covering intervals could overlap. That's possible. So then we define a concept, a simple concept. Compatible, mutually compatible activities. When you have two activities, they have some overlap intervals, overlap part in their covering intervals, then these two are not compatible because nobody can participate these two activities completely from beginning to end. Okay. So that's why we define this compatibility concept. But now we need to select a maximize subset. Yeah. With, but those any two activities in that subset must be compatible. That's the requirement. Yeah. All right. How to solve it? Yeah. So here, let us describe this compatibility, using math formula to describe it. What do you mean? What's the meaning of, two intervals are compatible? Yeah. Here, we use this formula. The covering interval for activity I, AI, the covering interval for activity AJ, the intersection of these two intervals is an empty set. If this condition holds, then we say they are compatible. AI and AJ are compatible. Yeah. So that's simple. Yeah. The formula looks pretty abstract, but that precisely gives us the meaning of compatibility. Yeah. Now let's look at the solution first. The solution is very easy if you just use the greedy algorithm. Very easy. Yeah. Here, let me give you the data. Here, I give you 11 activities with their, covering intervals. Yeah. All right? Yeah. Then, let's apply the greedy algorithm. The greedy algorithm, the straightforward way to select maximum number of activities with mutual compatibility property. Yeah. All right. So because greedy algorithm, let's just try our best to select activity as early as possible, right? The earlier the activity we select, then we can, put more just based on our intuition. Yeah. This intuition sometimes could be wrong. Yeah. Because our intuition, many times it may not be correct. So that is very common. Yeah. So that's why we need another step to show the optimality, because it cannot guarantee. This method itself cannot guarantee the optimality. So that's why we need to add another step to show optimality. Yeah. All right, so here, let's use the greedy strategy to select activity. The first one, let's pick the first one. Yeah. First one, yeah. All right. Covering interval 1 to 4, activity A1. Yeah. After we select this one, which one is the next compatible activity with respect to the A1? Okay, yeah. A2 not compatible, right? Yeah, because they have overlap. A3 not compatible, right? A4 compatible. So how about we just select A4, right? Yeah, A4, right? Then after we select A1, A4, A5 overlap. We can see overlap with A1 or A4. A6 overlap with A4. Yeah. If we find one overlap with one of the activities, then we drop it. A7 overlap with A4, right? Yeah. A8, no overlapping, right? No overlapping. Yeah. So we select A8. Yeah. The third one. Then A9 overlap it with A8. Yeah, 10, 11. Yeah, 11, no overlapping, so we select it. That's the one solution based on the greedy strategy. Yeah. So we can find it easily, but after we get this activity subset, can we say this is the optimal solution? Can we convince people nobody can find an activity subset containing 5 activities, more than this selection, 5? Can we convince people? We need to convince people this is the one of the optimal solutions. We may have multiple optimal solutions, but we only need to have one of the optimal solutions. We need to convince people. That step is hard. That step is really hard. Yeah. So let's go to that part. Yeah. To show the optimality, it is very abstract. So we need to do a lot of work. Convincing people, that's not easy. We need to show a lot of, logic reasoning to convince people. All right. First, so that is, I said this before. Some optimization problems can be solved by both dynamic programming and the greedy algorithm. Some of the problems, you can use either way to solve. When you have that situation, try greedy algorithm first. Simpler, easier to find a solution. But although, don't forget, you have the optimality. You need to show. That part is hard. But let's find a solution first, right? Let's get a fast solution first. Then later we try our best to show the optimality. All right. Here, let us define subproblems. So here we also define subproblems. We define SK as this subset of an activity for activities of the original set. With the condition, all the start time of the activity inside the subset AI greater or equal to the finish time of activity K. That is our definition. Okay. We need to use this subset to convince people we get an optimal solution. All right. Now, for this subset, we collect all the activities in the given set that are compatible. First, they must be compatible with AK. Second, but those activities must be after FK. Because compatible another way to get compatibility, one activity could be, before activity AK, right? Before the starting time of the activity AK. That's another way for the compatibility, but we don't take that. We just take compatible with AK, but after AK. That's the meaning. Then after that, while we use this set, we will write. All right. So because when we make our greedy strategy selection, we consider in this set candidates. When you select the next activity, we consider these candidates. All right. To understand the meaning of this set, let's look at the S1, K equals 1, S1. What are the activities for S1? How many activities can we find in S1? So we need to consider all the activities compatible with A1, but also, happen after A1. After A1. Yeah. All right. First one, A4 after A1, compatible. A6 after A1, compatible with A1. A7 also after A1, compatible. A8, A9, A11. Yep, so you can see. So based on our definition, so these activities that form S1 subset. Yeah. All right. Greedy choice. Now, based on our algorithm, we make our greedy choice among these activities. Yeah. How do we make that our greedy choice? Select AM as the activity in SK with the earliest finish time. Yeah. So here with different finish time, right? 7, 11, 6. Yeah. All right. Yeah. I mean 9, right? Yeah, not that. Not 7, 11. All right. A finish time 7, 9, 10, 11, 12, 16. Okay. Yeah. But this one has the earliest finish time. So our AM corresponds to this activity. Okay? That is our greedy strategy. Okay? Yeah. All right. Now, our next step is we want to show people we can get an optimal solution using this greedy strategy. We will get an optimal solution if we stick to this greedy strategy all the way to the end. We will get an optimal solution. How to convince people? Yeah. So let me show. We claim. Here we make a claim, but we need to prove it. Yeah. The claim you have to prove it's true. Yeah. What's the claim? AM is in an optimal solution. AM is in an optimal solution. Okay? Yeah. In. Yeah. Yeah. So if you select AM, you are on your way to an optimal solution. Okay? Yeah. You won't miss. You are on your way to get an optimal solution. So that's the property we want to show. Yeah, here. Yeah. How to prove it? Yeah. Next slide. Let's prove it. Yeah. So this step, very abstract. This is the hardest part. Hope you can follow. Yeah. All right. Here, so that is our notation. Yeah. Now we define another subset. We call it AK, capital A sub K. Be a maximum size subset of mutually compatible activities in SK. Can we do that? Yep. We can assume that, right? There exists a maximum subset. Yeah. Because the subset of this SK, finite number. There are finite number of subsets, right? Yeah. Among 5 finite number of subsets, definitely one can select an optimal or, a subset with maximum size subset, mutually compatible. Yeah, one can find that. Yeah. So we can assume AK exists. Okay. Yeah. All right. Another thing is a maximum size, because we may have multiple maximum size subsets. They have the equal number of activities, mutually compatible activities. So that's why we assume it is one of the maximum size subset. Yeah. All right. For example, in this solution, we have this 4 activity subset mutually compatible, but there is another 4 activity mutually compatible subset. Okay, yeah. So that's why it's not unique. Yeah. Yeah. So we're okay. We just take one of the optimal solutions. Yeah. Now let's prove. We assume this AJ, little AJ, be the activity in capital AK with the earliest finish time. Yeah. So it exists. So we take this activity out for some comparison. Yeah. Yeah. That's why I said it is very abstract. This step, very abstract. Yeah. Recall AM is in SK with the earliest finish time. AJ is in AK with the earliest finish time. What's the relationship between AJ and AM? First, we know AK is a subset of SK, right? Subset. AK is smaller than SK. Okay, all right. AM is the activity in SK with earliest finish time. AJ is in SK, smaller subset with the earliest finish time. Which one has the overall earliest finish time, earlier finish time? AM. Because when you find AM, you look at a larger subset, right? Yeah. Yeah. ASK containing AK. Containing. Yeah. Okay? Yeah. So that's why we can get, so here we can get one thing. Yeah. We compare the finish time. FJ. So which one is smaller? The FM should be earlier than FJ. Right? We should have that. Okay? Yeah. We should have that based on the definition. Yeah. But here, although we have that, okay? Yeah. All right. The first thing is, if AJ equals AM, then we're done. Right? AJ equals AM, they are the same. Yeah. Because AK, maximum subset mutually compatible, right? Yeah. Mutually compatible, you know, this containing AM, that's our claim, right? Our claim AM is in one of the optimal solutions. So this will give us optimal solution. Okay? You know, after AK, yeah, we'll select AK, but the remaining, you know, optimal solution. This will give us. So when AJ equals AM, our claim is true. Our claim is true. Okay? AK is in one of the optimal solution. It's true. So we don't need to prove anything. Yeah. All right. Now, what do we need to prove? AJ, AK different. So we assume AJ, AM different. When they're different, then we need to do a lot of work to prove, you know, our claim is still true. All right. Assume now we construct another optimal subset. Now, assume A prime, here, let's construct another subset, A prime, by modifying AK subset. How do we modify it? We remove AJ activity from AK, capital AK. Then we add AM into that set to get a different subset. We can do that, right? Just replace, because they're different. AJ, AM different. So we can replace AJ in capital AK by AM. That's the way we do the replacement. Now, after we do this replacement, first we want to show, do we still get a mutually compatible subset? That's the first thing. Second, optimal or not. After we prove these two things, we prove the optimality. We prove the claim. Then the claim keeps going, we get optimality. Okay? Yeah. All right. So this step, basically, we construct another optimal solution. Yeah, this way, we just try to get another optimal solution containing a k. Yeah, because our claim is there is one optimal solution containing a k. So we just do that. Yeah. First, a prime k and ak, these two sets have the same cardinality. Cardinality, number of elements in the set. So we call it cardinality. They have the same cardinality. Yeah? You replace one activity by another activity. So that's why they have the same number of elements or activities inside those subsets. All right. That's the easy to see part. Then mutually compatible condition. Now, next, we want to look at the mutually compatibility property. Yeah. So how to see that? All right, so let's draw a diagram. Okay, yeah. Let's put the, covering intervals of all the activities on this timeline axis. Time axis. Okay, yeah. All right. Suppose activity AJ covering this interval and activity AM covering that interval. Because we know FM less than or equal to FJ. Okay? So that's why, FM finish earlier than FJ. Earlier, based on our, analysis before. Okay? All right. Then we want to look at the remaining activities in those two subsets, capital A prime K and capital AK. Okay? Yeah. All right, so first we draw this line. In capital AK, all the remaining activity, because compatible with, mutually compatible, right? Yeah. Because this has the earliest finish time. For others, your finish time can only be after this line. Okay? Yeah, but compatible, so your start time also should be after that line. Right? So we can see all the other activities in capital AK must be after this line, that dashed line. Okay. Similarly, in A prime K, all the activity after that line. Okay, dotted line. Okay, all right. All right. Now we keep these activities. We replace AJ by AM. You can see we push the finish line to the left, right? Yeah. After this replacement, actually we push the finish line to the left. Then we do not violate the mutual compatibility property in the original set, right? We do not do any violation. This is the only change we do. Okay? Look at the change we do. The change we do, we push the finish line of its earliest finish line to the left. That won't cause any violation. Right? That's the observation we have. If you can see this observation, then you have no problem, no optimality violation. Then we prove the claim. So that AM falls in one of the optimal solutions. If we select AM based on our greedy strategy, we won't miss just one optimal solution. So we keep going this way, we will get an optimal solution, because we always stick to one of the optimal solutions to the end. So that's the argument. So that is, a little bit abstract. Yeah. But if you can understand, because this is, really you need to do a lot of abstract mind work. Yeah. That's not easy. Yeah. But if you couldn't follow, at least for the final, you do not need to worry. Yeah. If you have time later, you try to understand the best you can. But for your final, you don't worry about this particular problem. I won't create any question based on the understanding of this relatively hard question. Okay. All right. So that's all I have for this part, B.4 of lecture 12. And we finish all the lecture videos for this semester. But we will have a few more review videos, a few more, to prepare for your final. All right, so let me stop here. Yeah.